Hello, happy Monday. I'm so excited for this next lesson for this week because we are going to be looking at common factors. Today and in Zoom class tomorrow on Tuesday, we'll be talking about common factors and greatest common factor. Later on in the week, we'll be looking at least common multiple, and these two ideas right here, greatest common factor and least common multiple, are going to be so helpful for math for like the rest of your life. So I'm so excited for this lesson. Today we're going to use factors to solve problems. Our goals: I can explain what a common factor is. I can explain what the greatest common factor is. Notice that term greatest, that changes things a little bit. And then I can find the greatest common factor of two whole numbers. First, we're going to actually look at what the greatest common factor is. Now, you may be thinking right now, what is the common factor of two numbers? Miss Kimball, you keep using that word. I don't think I know what it means. The definition of the term common factor is a common factor of two numbers is a number that divides evenly into both numbers. For example, 5 is a common factor of both 15 and 20 because 15 divided by 3 equals 5 and 20 divided by 5 equals 4. So both of the quotients, 3 and 4, are whole numbers. So therefore, 5 is a common factor of 15 and 20. There are many ways to list the factors of whole numbers. If you have two whole numbers and you're trying to find the factor, a common factor of those two whole numbers, one thing you can do is just list them. So factors of 15 are 1 and 15 because 1 times 15, and 3 and 5 because 3 times 5 equals 15. Your factors of 20 are 1 times 20, 2 times 10, and 4 times 5. And when you look at this list, you'll see that they have 1 in common. All whole numbers will always have 1 as a factor, and 5 in common. So that means 5 is a common factor of both 15 and 20. Now in this scenario, 15 and 20, they only have one common factor. But there are instances where a pair of numbers have multiple common factors. In that situation, we always want to use the greatest common factor. The greatest common factor is a number that divides evenly into both numbers, but it's the largest number that divides evenly into both numbers. Oftentimes, you will hear me shorten that, or you'll see it shortened. Instead of saying greatest common factor, you'll see it as GCF. So for example, if you're looking at the numbers 45 and 60, and you want to find the greatest common factor, first you need to list the factors of both 45 and 60. So for 45, your factors are 1 times 45, 3 times 15, and 5 times 9. And your factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. And when you look, there's a lot of factors in common. They both have 1 as a common factor, 3 is a common factor, 5 is a common factor, and 15 is a common factor. When you want to find the greatest common factor, you look at which one of these numbers is biggest. So out of 1, 3, 5, and 15, 15 is the biggest number, so 15 is the greatest common factor in this situation. Now, as I've said, there are so many different ways to find the greatest common factor. You could do this right here where you put each number side by side and list the factors and then see which one is biggest. But what I found with this situation is a lot of times people are really good with their facts 1 through 12, but it's in like the 15s and the 20s that people forget about. So there's another way to find the greatest common factor, and that is what we call the upside down cake method. All right, so we're going to go through the steps of the upside down cake method to find the greatest common factor of two numbers. So first, you can find the GCF, greatest common factor of a pair of numbers, by using the upside down cake method. I call it that, and it's called this because it does kind of look like an upside down cake when you're done. First, you write both the numbers in the top layer of the cake. So you draw a cake like this. And in our situation here, we're trying to find the GCF of 54 and 36. So you write 54 on one side and 36 right next to it. And then you draw the cake, the top layer of the cake around it. You're going to divide those two numbers by a number that goes into both evenly. So 54 and 36, right away, because they're both even numbers, they both, one ends in a 4, one ends in a 6. I know that both those numbers can be divided by 2. So I write the 2 on the outside of the cake layer. Then you write the quotients in the next layer. So you divide 54 divided by 2. That's 27. So you write it down right here. And then 36 divided by 2 is 18. You write that down here. That's in the next layer of the cake. And then you continue dividing. Continue dividing the numbers by the same number that goes into both evenly. So with 27 and 18, this can both be divided by 3. So you write 3 on the outside of the cake. And then you write the quotients down here. 27 divided by 3 equals 9. That's in the next layer of our cake. 18 divided by 3 is not 3. This should be 6 right here, so that's a bit of an error. This should be 6 right here. So imagine that this says 6 right here. And then again, we can keep dividing. Both 9 and 6 can be divided by 3. So we write 3 out here, outside of the cake. 9 divided by 3 is 3. 6 divided by 3 is 2. And you continue going until all of the numbers in the cake are relatively prime. What that means is that you get to a point where the two numbers cannot be divided evenly by the same number other than 1. So in this situation here with 3 and 2, I can't divide 3 and 2 by any number other than 1. So I'm done. So what you do now is you have all these numbers on the outside of the cake on the left-hand side. What you do is you take those numbers that you divided by and you multiply them together. So we had 2, 3, and 3. 2 times 3 is 6. 6 times 3 is 18. So our GCF, the greatest common factor of 54 and 36, is 18. And I think that kind of looks like an upside down cake. We're going to do a couple more examples here. I'm going to show you one more example, do one together, and then we'll look at a real world example of when we would use greatest common factor. So here's another example on the left-hand side of the screen where you have 16 and 24, and we're trying to find the greatest common factor. So first you write 16 and 24 in the first layer of the cake. And because they're both even numbers, you can divide 16 and 24 by 2. So you write 2 on the outside of the cake. 16 divided by 2 is 8. That goes in the next layer of the cake. 24 divided by 2 is 12. That goes in the next layer of the cake. Then you keep dividing. Most of the time, 2 is a really good number to start with, because if you have two even numbers, they can always be divided by 2. So go with 2 again in this situation just to be safe. 8 divided by 2 is 4, make a new cake layer, put that here. 12 divided by 2 is 6, put that here. Again, they can both be divided by 2 again. 4 divided by 2 is 2, start a new cake layer. 6 divided by 2 is 3. Now, 2 and 3, we get to this stage where I can't divide 2. The only thing I can divide 2 by is 1 or 2. And the only thing I can divide 3 by is 1 or 3. So they are prime. That means there's no more dividing that is able to happen. So we take the numbers that we divided by. In this case, it was 2, 2, 2. On the outside of the cake, multiply them. 2 times 2 times 2, and get 8. So our greatest common factor of 16 and 24 is 8. So we're going to do one together. We're going to find the greatest common factors of 60 and 84. Now, first thing we need to do is write 60 and 84. Oops, that was super messy. Sorry, guys. It's hard to write on a computer screen. And 84, and put them inside of our cake, like so. And now I need to think, what's a number that I can divide both 60 and 84 by? Well, they're even numbers, so I can divide them both by 2. I'm going to put 2 on the outside of our cake. And then I'm going to divide. 60 divided by 2 is 30. Put that in the next layer of our cake. 84 divided by 2 is 42. And then make a new cake layer. Now again, I notice 30 and 42, they are both even numbers. They can both be divided by 2. So I put 2 on the left-hand side, outside of the cake, and now I divide. 30 divided by 2 is 15. 42 divided by 2 is 21. Make a new cake layer. Same thing. What can both 15 and 21 be divided by? Now in this case, it's not 2, because I can't multiply anything by 2 to get 15 or 21. So it's not 1, because 1 wouldn't do anything. And it's not 2, let me think, 3. Now I can divide 15 by 3, and I can divide 21 by 3. So I'm going to go with 3. 15 divided by 3 is 5. 21 divided by 3 is 7. And now I'm going to stop here. I'm going to stop here because for 5, the only thing 5 can be divided by is 1 and 5. And 7, the only thing that 7 can be divided by is 1 and 7. So these numbers are prime. That means we are done. Now I need to take these numbers right here, the numbers we divided by, and multiply them together. That will give you your greatest common factor. So 2 times 2 times 2, or no, I'm sorry, times 3. There we go, times 3. 2 times 2 is 4. 4 times 3 is 12. So our greatest common factor of 60 and 84 is 12. What we're going to do now is go on to our next slide and look at an actual real world example of when we would use greatest common factor in order to solve a real world problem. So we're going to look at Diego's bake sale. We're going to read the problem. Then we're going to go back and read it a few times to make sure we really understand it. This is something we did a lot in class, and we want to continue to do that online. This is our problem. Diego is preparing brownies and cookies for a bake sale. He would like to make equal size bags for selling all of the 48 brownies and 64 cookies that he has. Organize your answer to each question so that it can be followed by others. Just going to look at that first two parts. So first, what is the situation about? Let's go back and read it and make sure we know what this is about. Diego is preparing brownies and cookies for a bake sale. He would like to make equal size bags for selling all of the 48 brownies and 64 cookies that he has. So this problem's about Diego at a bake sale. He's going to be selling brownies, 48 brownies. He's going to be selling 64 cookies. And it sounds like he wants to make equal size bags. That means each bag would have the same amount. All right, that's our first read. Let's see what our second read is. What is countable or measurable in this story problem? So in this story problem, the 48 brownies is countable and the 64 cookies are countable. Then how might you begin to solve this task? Well, if I want to know the equal amount in each bag, I'd start, when I hear equal amount, I think dividing. So I think I'd want to start by dividing. So here's our problem one last time. Diego is preparing brownies and cookies for a bake sale. He wants to make equal size bags for selling all of the 48 brownies and 64 cookies that he has. And we're going to organize our answer. So 1, 2, so on. Number 1, how can Diego package all of the 48 brownies so that each bag has the same number of them? How many bags can he make and how many brownies will be in each bag? Find all of the possible ways to package brownies. Okay, wow, like there's a lot of ways that he could do that because there's so many ways to divide 48. So what I'm gonna do is I'm just gonna list all of my different factors of 48 to get started. So obviously it's 1 times 48. You could also do 2 times 24. I believe 3 and definitely 4 times 12. And then 3 times 16. And then 6 times 8. So like, wow, that's a lot of factors for 48. So I'm thinking he could make 48 bags with 1 brownie in them. So one possibility is 48 bags, each with 1 brownie. Another possibility is 24 bags, each with 2 brownies. Another possibility is 12 bags, each with 4 brownies. Or 16 bags, each with 3 brownies. 8 bags, each with 6 brownies. Or even 6 bags, each with 8 brownies. Or even 3 bags with 16 brownies. Or 2 bags with 24 brownies. Or 1 big ginormous bag with 48 brownies. So there's so many different combinations right here. So we found all of our factors of 48, and we were able to make so many different combinations of bags and brownies. We want to do the same thing with the 64 cookies. So how can he package all of these 64 cookies so that each bag has the same number? And we want to list the number of bags and the number of cookies. So thinking of our factors, I know definitely 1 times 64. And then well, 64 divided by 2 is 32. So 2 times 32. And then 64 divided by 4 is 16. So 4 times 16. And then I know 8 times 8 is a factor of 64. And then those are all of our factors for 64. So let's make our possible combinations. So again, we could do 64 bags, each with 1 cookie. Or we could do 32 bags, each with 2 cookies. Or we could do 16 bags, each with 4 cookies. Or we could do 8 bags, each with 8 cookies. This would be big. This would be a lot of cookies. So we have all of these possible combinations here. And now for the next problem. Number 3 is asking us, how could Diego package the brownies and the cookies together so that he has the same number of bags, but that maybe a different number of cookies and brownies in each bag? Because he wants the same number of bags of cookies and brownies. And he doesn't care if there's more cookies in one bag than the other. So that's when we want to look at our factors that we have listed for the 48 brownies and the 64 cookies and see what they have in common. Well, they both have 1, 2, 4, and 8, and 16. And when you look at the possible combinations here, each one has a combination with 16 bags. So Diego could possibly make 16 bags, each with 3 brownies and 4 cookies in it, and sell that at the bake sale. So this right here is a real world example of when you would actually use greatest common factor and why it's important. And again, this is one way of finding greatest common factor. List the factors of each number. We could have also gotten this answer by doing our upside down cake method, and we'll do that on the next slide. If I can get to the next slide. So how can Diego package all the 48 brownies and 64 cookies so that each bag has the same combo of items? So we want to find the greatest common factor in this situation right here. And we can do that with our upside down cake method. So write 48 at the top of the cake and 64 and put it inside the top cake layer. So super appropriate that we're talking about cake for a bake sale. So right away I can tell that both of these numbers are even, so they can both be divided by 2. So I'm going to put a 2 out here. 48 divided by 2 is 24. 64 divided by 2 is 32. Make a new cake layer. Again, 24 and 32, both even numbers, both divisible by 2. 24 divided by 2 is 12. 32 divided by 2 is 16. Make a new cake layer. Find the next common factor. 12 and 16, again, both even numbers, both divisible by 2. Notice there's a pattern. 2 is very, very helpful. 12 divided by 2 is 6. 16 divided by 2 is 8. Make a new cake layer. And 6 and 8, again, you guessed it, both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And now with 3 and 4, The only number they're both divisible by is 1. So we're done. We can't keep dividing anymore. But we want to take these numbers on the left that we divided by and multiply them. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our greatest common factor is 16. In this situation, that 16 means that he can make 16 bags, and each bag have the same combination of cookies and brownies in them. So what I want you guys to do is, if this is still a little bit unclear, go back and rewatch certain parts of it, or even start to watch some of the videos on Khan Academy. This week's graded assignments are all on Khan Academy. It's going to be videos to watch and lessons to complete. I don't assign the videos just because I feel like making you guys watch videos. They're super helpful. They explain what you're doing in the lessons, and it's somebody explaining things in a way that's different than the way I explain things, which may be helpful for some of you. He's more precise than I am with my language, which again is very helpful for some of you. So watch the videos, complete the assignments, and come to Zoom class on Tuesday at 12. Not only do I want to see your beautiful faces, but I also want to make sure that you understand greatest common factor, because it's super important for math and life in general. So I hope to see you all there on Tuesday at 12, and I hope you all do your Khan Academy assignments. I'll see you tomorrow. Bye.